Hi everyone, welcome to Prof K YouTube channel. So today we'll be dealing with vectors. So let's start with the scalar. Let's start with scalar first. Scalar. So this is a quantity having magnitude but no direction. So you know what a scalar is. A scalar is a quantity having just only the magnitude but no direction, just only size but no direction. So that's what scalar is. So this is a quantity having magnitude but no direction. So what are the examples of scalars? So examples are, we have length, mass, time, we have distance, we have speed, we have area, we have volume, we have temperature, we have density, we have work, we have energy, we have power, we have pressure, we also have current, and we also have charge, and we also have resistance, and we also have potential difference. Then we also have a real number. So a real number is also a scalar. Because what do we mean by a real number? Real number is just something like 1, 2, 3. So that's what is real number. So and what is it? It's just dealing with size, just the magnitude. So that is a real number is also a what? It's also scalar. So and you also know that current is also a scalar because current is different from charge. You all know what current is. Current. You know this is the symbol for current, I. So and you know what charge is. Charge is this is the symbol for charge, Q. So there are two different things. What is the unit of current? The unit of current is in what? Ampere. While the unit of charge is in what? Coulombs. So there are two different things. So they are both scalar. So these are the examples of scalar. So you have to know this offhand. You have to know everything offhand. Because if, let's say, for example, now your exam is a CBT exam, a computer-based exam. So they can ask you which one is not a scalar, which one is not scalar. Shall you get? So if they ask you which one is not scalar, they can list time, mass, temperature, impulse. They can include impulse. And is impulse a scalar? No. So impulse is vector. So we'll come to that what. These are the examples of scalar. So you have to know it offhand. You have to know it offhand. You have to know everything offhand. And they can group it for you. They can say option A, mass, time, temperature. Option B, they can include speed, area, impulse. Option C, they can you get what I'm trying to say. So they can just scatter it anyhow and say which one is the correct answer, which one is a scalar among all. So you have to know all these examples offhand. You have to put it offhand. So what do we mean by scalar? Scalar, these are the quantity having only magnitude but no direction. So they only have magnitude but no direction. So and these are the examples. So please put everything offhand. So let's come to vector now. Vector. So these are quantity having what? Both magnitude and direction. So that's just the difference between scalar and vector. So scalar is the one that is having magnitude but no direction, while vector is one having both magnitude and what? And direction. So that is a vector. This is a quantity having both magnitude and direction. So vector is usually represented in capital letters. So when you see something like this and you see an arrow on top, it is a vector. That's vector. So these are vectors are usually represented in what? In capital letters. So these are the examples. Then the components are in small letter. The components are in what? Are in small letters, such as, look at it. So these are the components of these vectors. So these are the components. So they are represented in small letter. Or you can also see it this way. You can also see it this way, just a line under. So this is also vector. So the arrow on the letters help to differentiate a vector quantity from scalar quantity. Shall you understand? So you just like what I said, scalar, they have magnitude but no direction. While vector, they have both magnitude and direction. So the arrow on top is to show is a what? Is a vector. So it's showing the direction to which it's going. So that's what the arrow on the letters help to differentiate a vector quantity from scalar quantity. Now, what are the examples of vector? So we have displacement, we have velocity, we have acceleration, we have force, we have weight, we have momentum, we have torque, we have impulse, we have electric field, and we also have magnetic field. So these are the examples of vectors. These are the examples of vector. So displacement, velocity, acceleration, force, weight, momentum, torque, impulse, electric field, and also magnetic field. So these are the examples of, and so on and so forth. There are still more to it, so you can just check for others, but these are the ones I could get. So displacement, velocity, acceleration, force, weight, momentum, torque, impulse, electric field, and magnetic field. So these are the examples of vectors. Now, representation of vectors. Representation of vectors. So the magnitude and direction of vector may be represented by the line OP. The magnitude and direction of vector may be represented by the line OP, directed from the initial point O to the terminal point P, and is denoted by, this is it. So it is denoted by this. So here the length of the vector OP, the length of the vector OP denoted by this. Once you see something like this, like a slash, once you see something like this, so it is called magnitude, or you can also call it modulus. It is called magnitude, or you can also call it modulus. So magnitude and modulus is the same thing. So if they ask you to find the modulus, it's also the same thing as saying find the magnitude, so, of the vector. So let's say we have a vector O in the direction of P, then the vector there is A. So similarly, we can say vector A is equals to from O to P. See that the initial point is what? Is O. Then the terminal point is what? P. So how do you get it? How do you get the length there? It will be P minus O. It will be P minus O. Let's say we have a vector AB. Vector AB. How do you find the length? It will be what? B minus A. It will be B minus A. Sure you get? It will be B minus A. Let's say we have CA now. CA. How do you find the length? So it's going to be what? A minus C. The one at the back first minus the one in front. You get? So the one at the back, then minus the one in front. So, and so on. So if you are told to look for, let's say, AD, so it will be what? D minus A. So it will be D minus A. So this is how vectors are represented. So this is how vectors are represented. So let's go to types of vectors. Types of vectors. So we have the negative vector. We have the negative vector. So this is a vector having the same magnitude as A, as vector A. This is a vector having the same magnitude as vector A, and whose direction is opposite to that vector A. So that's what we mean by a negative vector, and whose direction is opposite to that vector A. So it is denoted by what? The negative of that vector. So once you see something like this, so it's opposite to the direction of that vector. So, and number two, we have a unit vector. So this is a vector having a unit magnitude. This is a vector having a unit magnitude. So the magnitude of that vector, if it's equals to 1, it is called a unit vector. So the magnitude of that vector, if you are told to calculate the magnitude of vector and you get 1, so it is also called a what? A unit vector. So please put it offhand. So this is a vector having a unit magnitude, that is, the magnitude of that vector is equals to what? 1. So if the magnitude of that vector is equals to 1, so that's what we know as what? Unit vector. So if A is a magnitude of A, let's say A now is a magnitude of vector A, then that vector A can be expressed as a unit vector. So we have it as this. So just the formula for a unit vector, if you are told to look for a unit vector, this is the formula. A unit vector is equals to what? That vector over the what? Over the magnitude. So this is what we have here. So this is what we have here. So to calculate where this A now represent the unit vector. So this is the formula to calculate a unit vector. Don't worry, we'll be solving examples with it. So this is the formula to calculate a what? A unit vector. Put it offhand. This is the formula to calculate what? A unit vector. So vector A, a unit vector is equals to vector A over the what? Over the magnitude of that vector. So the third one, we have collinear vectors. Collinear vectors. So two vectors A and B are said to be collinear if there exist lambda such that vector A is equals to lambda multiplied by vector B, such that vector A is equals to lambda multiplied by vector B. So this is what we mean by a collinear vector. So two vectors A and B are said to be collinear if there exist lambda such that vector A is equals to lambda multiplied by vector B. So otherwise it is said to be non-collinear vector. So otherwise it is said to be non-collinear vector. So the last one, we have a coplanar vectors. We have coplanar vectors. So three vectors A, B, and C. Three vectors A, B, and C are said to be coplanar if their scalar triple product is what? 0. If their scalar triple product is what? 0. So if the three vectors, if their scalar triple product is 0, then it is known as what? Coplanar vector. It is known as coplanar vector. That is, vector A dot, this is dot. So in vector, it is called dot. Vector A dot into bracket vector B cross. This is cross, not multiply. This is cross. In vector, you call it cross, not multiply, not multiplication. So vector A dot into bracket vector B cross vector C. So if the scalar triple product of all this is equal to 0, so it is known as coplanar vectors. So it is known as what? Coplanar vectors. So this is just a summary of the starting of vectors. So don't worry, we'll be solving examples. A lot of examples. Sure you get. We'll be solving a lot of examples. So do well to subscribe. Do well to subscribe to the YouTube channel. Then also like, comment, and share. Sure you get. So stay tuned. We'll be solving examples very soon.